Woohoo, and welcome back. Today we're going to be talking about part 3 of 4.3. Now, this is a very long section with multiple parts, and today's is probably the most complicated part. So before we dig into it, I wanted to review a little bit about the difference between equality and inequality. So let's dig into equality and inequality. When things are equal, you get exact answers. Now, that's not really mathematical talk. That's human talk. For discrete, there are individual answers. For example, if we look down here, if we've got x equals 4, how many answers are there? Just one. It's 4. Just a dot on the number 4. And for us, usually up till now, it's been 1 or maybe 2 answers. There won't be a lot of answers with equality. For us, with equality, we'll get a limited number of answers, and they will be individual points. Now, what's going on with inequality? Well, with inequality, so less than or greater than, or less than or equal to, or greater than or equal to, we're going to get a range of answers. This is, in math, considered continuous as opposed to just points, which is discrete. Usually, we'll be looking at an infinite number of answers. Because, for example, how many numbers are less than 4? Well, a whole lot of numbers are less than 4. I wrote down a few of them: negative 17 thirds, 3, 1.5, negative 5, 0, negative 100,000, etc. So usually we're talking about an infinite number of answers. So we can't just draw points. When we've got an inequality, the way we represent the answer is either with the inequality or with a graph that shows a range. In the same way, if I said, for example, if you're at the carnival and you have to be at least 4 feet tall to ride on a ride. Now that would be the opposite of this one. This is less than 4. But if you have to be at least 4 feet tall, you could be a lot of heights. You could be 4'1" or 5 feet or 6 feet or even 7 feet tall. But you couldn't be anything less than 4. So it's going to be a range of answers as opposed to discrete answers. In the first part of 4.3, we were working with equalities. So we were coming up with exact answers. And for absolute value, that meant 2 answers. Now we're going to be moving into inequalities with absolute value. So here we are taking if I were going to list the things people really don't like about math, obviously word problems. No, and thankfully no word problems. Yay! Fractions. I can't remember if I have any yeah, there's some fractions in here. Ugh. So we got fractions. Okay, but we can totally do this. Absolute value and inequalities, less than or greater than, those really are the things that a lot of people struggle. Because one, they don't come up a lot in math, and so we don't get as much practice. And 2, they're some really complicated concepts. In terms of a puzzle, this is a big deal. So be gentle with yourself, take breaks, and as always, if you have questions, please reach out to me or to a tutor. Ask lots of questions. Okay, let's go ahead and dive in. The way I'm going to approach this is, rather than just telling you how to do it, I'm actually going to do some work around thinking about what the answer would look like. So, I want to solve the inequality that the absolute value of x is less than 4. So if x were less than 4, like this, we would just get the answer all the numbers less than 4, right? This is a little more complicated because this is the absolute value of x. And if you're ever struggling with a problem like this, one of the possibilities is just to try different things. So let me try a bunch of different numbers. So for example, it looks like a cat or a rabbit has been walking on my notes. Sorry about that. So when x equals 0, the absolute value of 0 is 0. That's less than 4, so yes, that is a solution. How about 1? Absolute value of 1 is 1. That's less than 4, so this is a yes. Okay, 2, absolute value of 2 is 2, is less than 4. Yep. Absolute value of 3 is 3. That's less than 4. Yep. Absolute value of 4 is 4. Oh no. That is not less than 4. Nope. So that's a big no. And then 5 is right out, because absolute value of 5 is way too big. Nope. Now I'm going to say that this notation where I'm crossing out the inequality, not as common. So this is just something I'm doing for the lecture. In fact, there are other ways to write it as well. I'm just using it right now. Okay. So on this side, we're kind of getting what we're expecting. The numbers that are smaller than 4 are in, and the numbers that are 4 or greater are out. Okay, easy peasy. Now let's talk about negative numbers. So this is where absolute value starts to really shine. The absolute value of -1 is 1. That's less than 4. So yep, that's in. -2, okay. Absolute value is 2. That's less than 4. Yep. -3, absolute value of -3 is 3. That's less than 4. Yep. So everything is going great until we get to -4. -4 inside an absolute value is 4. So even though -4 is less than 4, the absolute value is not less than 4. So that's a no. And -5, well, that's absolute value of -5 is 5, which also not less than 4. Interesting. So now let's graph the solutions. Okay. Now, you'll notice that because I didn't have an infinite amount of time, I only looked at the integers. Are there other numbers on a number line? Oh my gosh, yes. There are an infinite number of points on a number line, right? I just looked at the integers because those would be the easiest to think about. But we also have all the numbers between -1 and -2, like -1.5, -1.673. Tons of numbers. I just didn't look at them. So we're just going to graph these numbers and see if we see a pattern. 2, 3, 4, 5. So there's 4, there's 5, -1, -2, -3, -4, -5. Okay, so the yeses, let me see if I can find a yellow. The yeses are going to be 1, 2, 3, and -1, -2, and -3, right? Those are my yeses. Yeses right there, yeses right there. Okay, so 1, 2, 3, -1, -2, -3. So far, so, oh, and 0, yes. Now, I know that 5 is not a point. I think I was going to think about graphing that, but I think I'll leave it out because I think that might make it too complicated. So, but what happens at 4? At 4, we're right on the edge. So everything less than 4 would work. So I'm going to put one of these right there. If you prefer, you can also use an open circle at that point. It just depends on what your style is. Same thing at -4. -4 is right on the edge because it's the first number that isn't less than 4, if that makes sense. Because -3.9 totally works. -4, no good. So this is kind of a boundary too. And that's where I'm asking your brains to stretch a little bit. So that might be the thing that you need to ask a tutor or ask me. Let's talk about it more. But I'm going to claim that, in fact, the answer is that everything between -4 and 4 is a solution. Now that's really interesting. We've got an absolute value, and before with the equations, we got how many answers? We got 2 answers, +4 and -4, right? But with an inequality, we get 2 endpoints and all the numbers in between. That's really interesting. Next up, and this is the solution. That is correct. I know we were pretending like, oh, let's figure this out, but I actually do know what the answer is. So the answer is this. And I know you're all like, is it though? And I'm telling you, yes, it is. And I will show you what the rule is in just a moment. So use the previous problem to solve the absolute value of x is greater than or equal to 4. And here's what I'm going to claim. Claim every point, so every value of x is either less than, or sorry, I said less than and my brain totally didn't help me with that one. Sorry about that. My hands like to do all funny things. So every value of x is either less than 4 or greater than or equal to 4. I'll give you a moment to think about that. That's my claim. And I know it's hard to think about when the paper is sideways, so there we go. Ugh. Okay. Every value of x is either, so any number you can think of, 10, greater than or equal to 4. Negative 12, less than 4. 138,000, greater than or equal to 4. 4, greater than or equal to 4. 4 is equal to 4, so it falls into this category. So if all the numbers are one or the other, and these are all the ones that are where the absolute value is less than 4, then if I draw exactly the same number line, I just include all the numbers here that I didn't include there. So I'm going to start at 4 and go out to the end. So everything bigger than 4 or everything smaller than negative 4. And why that one kind of makes sense, but why the heck is that one? Why do we have that? Well, we have this because what's happening? Well, I'm taking x and I'm taking the absolute value, which means I am snatching away that minus sign. So all these numbers over here, like a negative 4 or negative 5 or negative 10, suddenly look like 4, 5, and 10. Suddenly I'm making them big positive numbers. So that's why they are also included. Now, you might ask me, well, how the heck do I even write this? It's not one interval. And you're right, it isn't. So it's kind of annoying. These are not my favorite, but the way that it works is you start from negative infinity, which are, oh, my hand is so funny today. My hand is just all over the place with bad math. Okay, let's try this again. Negative infinity to negative 4. And then we jump over the middle and we start at 4 and we go all the way out to infinity. Which is also, this can be written a few ways. X is less than or equal to negative 4, or x is greater than or equal to 4. You could write it that way. Of course, up here, and I didn't include it, but I could right now, the interval would be from negative 4 to 4. It's a lot easier because it's just one interval instead of two of them. Remember that the big capital U that doesn't have any sticks in it, it just has one big swoop. That means the union of these two. So it means put these two together. Okay. So far, so good. Everything seems pretty reasonable. Yay! So looking at all of this, what the heck is the actual rule? And that is a really much more complicated situation. So let us look at the rule. So if you have the absolute value of x is less than or equal to a number, and we'll call it k. I don't know, for Catherine or something. Then we've got the smaller than version. And the smaller than version stays close to home. When you're young, when you're small, you have to stay close to home. So you stay close to 0. You stay in the middle. Okay, so that's this answer. Does that make sense? And if I have absolute value of x is greater than k, that means you've gotten bigger, you're older. So that means x is less than the opposite of k, or x is greater than k. So it's that two pieces, that feeling that you've got the opposite of k is over there, and k is right here. There we go. Woohoo! What do you think? So if you're less than, you stay in the middle, and if you're greater than, you go to the ends. Now, I already hear you saying, wait a minute, what if you've got an equals? If you've got an equals, if you've got an equals there, you add equals to both of the inequalities, and you take those parentheses and you harden them into brackets. Same thing here. If this is a greater than, then these become, or sorry, greater than or equal to. This becomes a less than or equal to. This becomes a greater than or equal to. These become hard brackets, and the shape stays the same. Okay. I know this particular piece of paper is the one that people look at and they're like, oh my goodness, what am I going to do? So let me move this over here. Oh, you can see a little bit of my little cat cup right there. That's my little, those are the stripes. Can you see the vicious puma? There's my vicious, it holds my pens right there. Ooh, it's my vicious puma right there. So this is the sort of thing that a lot of people look at and they're like, oh, that's it. Math is not for me. Okay, so let's talk. The truth is that when you're taking a math class, an A only requires that you get 90% or more. You don't necessarily have to understand every detail. So is it possible that you'll get through this class and this will be something you will have to study more in the future? Absolutely. Second question, how far are you going to go? If you're going to go on to calculus, this is really important. And you should talk to the tutors, you should talk to me, talk to your next teacher, keep working on this. A lot of times it's a lot, so you won't get it right at first. You'll understand parts of it, but some parts will be maybe not so easy. Keep working on it. Those of you who are not going to calculus, if this is your last math class, I gotta say, I don't think this actually comes up in the real world much. As an adult person who's lived quite a few years, this has never happened like on a train or, on a vacation. Someone has asked me this, except, students asking me questions. So can you still be a productive, happy human and never understand this? Absolutely. However, it is my job to try to help you understand. So I've got two examples here. And again, talk to me. I'm happy to do more of them to show you how I would set this up. Okay? So first thing, you've got to identify what's going on. Well, it hopefully is very clear when you've got absolute value and you've got an inequality, a less than or a greater than somewhere, then you're in this land. Second step. Let's go ahead and figure out, are we in less than or greater than world? This first one is a less than or equal to, so we're in the less than world. Okay, so the less than world I personally think is a little easier. What you do, I don't actually break it into two pieces. I do it all as a single line. It's called a double inequality. Sometimes I think there's some other words for it, but what you do is you take the 3x minus 2 and you put it between, you sandwich it in the middle of -4 and 4. Remember, we talk about absolute value creates those two endpoints. Those are the endpoints. And because basically it's a less than or equal to, which falls into the less than world, you stay in the middle because you're little. And so you can imagine, like, these are your boundaries when you're small. You don't want to go too far because you're little. So I'm going to go ahead and just solve this as I would solve any other inequality, except this has, 3 sides to it. I add 2 to all 3 sides, and I get negative 2 is less than or equal to 3x, which is less than or equal to 2. And then the last step is I'm going to divide by 3. Negative 2/3 is less than or equal to 3x over 3, which is less than or equal to 2/3. I'll go ahead and use a little room over here. I get negative 2/3 is less than or equal to x is less than or equal to 2/3. And I already see an error. Do you guys see my error? Oh my goodness. Yes, I see it too. You probably were throwing things at the screen. Do you guys see it? What did I do? 4 plus 2 is 2? Oh my goodness. Seriously, I'm going to have to fire myself. But then, who would make these videos? Okay, well, with enough whiteout, you can make mistakes. I totally meant to do it. What? I was showing you just how it's just totally normal to make mistakes. Sometimes you have to go back and recheck your work. Thank you for your patience, guys. Okay, 4 plus 2 is 6. Then we've got 6 divided by 3. And over here, 6 divided by 3, which means negative 2/3 less than or equal to x, less than or equal to 6 over 3, which is 2. And that was what my brain was trying to do. My brain tried to skip some steps. Sorry about that. I know that's confusing. So again, 4 plus 2, add 2 to all sides. Negative 4 plus 2 is negative 2. The negative 2 and the positive 2 cancel out. 4 plus 2 is 6. And then I divide everybody by 3, and then I simplify. Okay, let's go ahead and graph it. Now, my rule for graphing is if you already have 2 values, don't try to give too much detail. These are less than or equal to, so I'm going to have brackets. The first bracket is at negative 2/3, and the second bracket is at 2, and we're going to be looking at all the space in between. Now, sometimes people will put an X there at the end. You don't have to. I've seen a lot of people not do that. A couple books like it, and it's up to you. Now, if you feel compelled to put 0 in, should you put it right in the middle? And the answer is no. Negative 2/3 is way closer to 0 than 2 is. So, I don't know. I would have to eyeball. It would be very difficult, but the 0 would go somewhere in there. But I don't personally feel the need to put it there. And then if you really need to write the interval, it would be negative 2/3 all the way to 2. And why are these hard brackets? Because it's a less than or equal to. If this had been strictly a less than, these would be parentheses. Woohoo. Okay? Okay, that's one down. Let's try the next one. Now this one, I personally think this is the harder of the two. Doesn't mean it's going to be harder for you. I just think there's a lot going on in the greater than world. This one, you've gotten older. You've got an absolute value, which means we're looking at endpoints. It's an inequality, so it's going to be this range, but it's a greater than. So we're in this world where we're on the outsides. So this one, you really have to do in 2 parts. I've seen people try to force this into a single double inequality, but it doesn't work. So the good news is the first piece of it looks just like with inequality. You just drop the absolute value. So you write 4x plus 2 is greater than 6. And then you also have, though, 4x plus 2 and negative 6. Now, so far, this looks just like an equality. You've got the positive 6 and the negative 6. And the only problem is you have to remember to change the equality there, the inequality. You have to turn it around. The greater than becomes a less than, because you want to end up with both sides. This is a greater than situation. This is a less than situation. Why did the inequality flip? Well, it's because the 6 transitioned to a negative 6. So whenever you're playing with minuses, inequalities flip. Okay. There we go. Okay, so now we can solve each of them. subtract 2. Hopefully I don't get too distracted because, well, I'm still talking. I'll do this silently. It'll be a ASMR, a quiet, scratchy noises for your listening pleasure. So that's the first one. Now, in this case, it was really nice because we ended up with all integers. So it's not as hard to graph necessarily as this one. I've got x is greater than 1. So I'm going to start, let's see, I've got 1 here, -2. And again, as long as I don't try to put in 0, I can just put these two numbers anywhere I want. 0 would not go in the middle. It would go closer to the 1, right? Go about there. Okay, so I'm going to be greater than 1. So I'm looking like that. Or less than -2. And while you're asking me, I can hear you thinking, well, why are these soft parentheses like this instead of the brackets that are up here? And the answer is because this is just a strict greater than, not a greater than or equal to. And here we have our answers. So you could write x is greater than 1, x is less than -2. Or you could write -infinity to -2, jump over 1 to infinity. That would be the interval notation. And there's the graph. Oh my goodness, you guys, you made it through. Congratulations. This was a lot. And I understand. I don't think any less of you if you're just looking at this going, oh my goodness, this is a lot. It really is a lot. But I hope that with a little bit of practice, it actually feels a little bit easier. And again, just a caveat, if you are going on to calculus, this is something you want to get sorted. So ask lots of questions. And even if you're not going on to calculus, even if you never need to learn this, it does feel good to figure stuff out. So please, don't stop asking questions. If I'm not giving you the answers that make sense, keep asking or talk to a tutor. Frequently, tutors can do it in a really different way that connects better with students. So awesome, take advantage of that. And, remember to get outside, get some exercise, hydrate, take care of yourselves, and give yourself, a gold star. You made it through what I think of as one of the hardest sections in this class. So keep being awesome. Woohoo. Math on.